Dividing radicals. If the nth root of a number is divided by the nth root of another number, then the result is the nth root of the quotient. So given here is an example, nth root of p all over nth root of q is equal to the nth root of p over q. So remember this property. So we have here some examples to answer. Let's move on to the next slide to start with letter A. So A, square root of 5 over square root of 8. So first is to transform the denominator, which is square root of 8, to exponential form. So this is equal to square root of 5 all over square root of 2 cubed. Next is to rationalize. So we're going to rationalization, where we multiply the numerator and the denominator by the square root of 2. Make sure that if you're going to add the exponent here, 3, and the exponent here on your denominator, it will result to a number that is divisible by your index. The index is here is 2. So the sum of this exponent should be divisible by 2. So first, it is only possible if the exponent here is 1. We're going to use 1 as the exponent here. Now let's multiply. Equals, multiply the numerator, square root of 5 times square root of 2, that is square root of 10, all over. Then we multiply the denominator. That will give us square root of 2 raised to 4. And then, of course, the exponent here is 4. The index is 2. So you can simplify this one to copy the numerator. And then this will be simplified to 2 squared. You can get 2 or obtain 2 by dividing this 4 by the index. 4 divided by 2 will give you an exponent of 2. Then, for the final answer, we're going to have your square root of 10 over 4. So this is the answer for letter A. Next, letter B. We have here 2 square root of 3 divided by cube root of 2. So again, you're going to multiply this based on our denominator, which is cube root of 2. Multiply that by cube root of 2. Then identify the exponent here. So the exponent here should have a sum of 3, or it's either it should be divisible by 3. So in this case, we need to have a 3 here on our denominator as the exponent. So I need to add here, if there is 1 here, I need to add 2. 2 plus 1 will give me 3. Alright, so just copy this exponent to your numerator. Equals, now let's multiply. This will give us, first multiply the numerator, is 2, then square root of 3, and then you have your cube root of 4. And as you can see, you cannot combine these two radicals since they have different index. At the same time, they also have different radicand. So you just let it be that way all over. And then we can have here cube root of 2. And then adding 1 plus 2 will give you 3. And then you can simplify this one to eliminate the radical sign. So since, again, looking at this one, the exponent and the index are the same, so that will just result 2 for your denominator. So this is going to be 2 square root of 3 cube root of 4 all over 2. And of course, you can simplify 2 here. So for the final answer, that is equal to square root of 3 times the cube root of 4. Last, letter C. Divide the square root of 7 by 2 plus square root of 3. So, as you can see, the denominator here is a binomial. So, all you have to do is to use the conjugate pair. Multiply this fraction, this rational expression, to its conjugate pair, which is 2 minus square root of 3. 2 minus square root of 3. Conjugate pair is where you change the sign between the two terms. If the given uh, sign here in your denominator is positive, you're going to change that to negative. Then just copy what is in the denominator to your numerator. And let's multiply. Using distributive property for your numerators, square root of 7 times 2 is 2 square root of 7. Then square root of 7 times negative square root of 3, and it's negative square root of 21. All over. And then, of course, in multiplying conjugate pair, I just need to multiply the first terms and the last term. So 2 times 2 is 4. And then you have your plus minus. So minus, for the last term, that is minus 3. So our answer here is 2 square root of 7 minus square root of 21.